To Algebra 2 Pre-Calculus. We're doing section 9.3 in Pre-Calc, which is geometric sequences and series, and we're going to go ahead and do an example directly out of the book. We're going to do example 8 on page 639, which is an increasing annuity savings plan, and we'll talk about that in a sec. But it was one of those things where it seemed easier to use the construct that already existed. So I'm going to read you the paragraph from the book. If you want to actually see the paragraph, you're welcome to go to page 639 in your Pre-Calc textbook. So example 8. A deposit of $50 is made on the first day of each month in a savings account that pays 6% interest compounded monthly. What is the balance at the end of 2 years? This particular type of savings plan is called an increasing annuity plan, so let's walk through exactly how that works. So if we want to write this out, right, so we're going to do a flashback to some Algebra 2, right? In Algebra 2, we learned that if you have a compound interest account that is compounded on some regular basis that is not continually, use the formula that the amount at some time t in years is p times 1 plus r over n to the nt, right? Where p is your principal, meaning your starting amount, so in this situation that's 50. The r in this formula is the 0.06, which is the rate at which you're getting the interest. The n is 12 because they said monthly, and in this problem, t is going to be 2 years. So essentially what's happening is we get 24 months in this situation. So let's walk through what this looks like if we were to write out these terms, right? So the first deposit that I'm going to make, right, the very first deposit I'm going to make is going to, over that course of the 24 months, make 50 times 1 plus the 0.06 over 12 to the 24, right? Because it's going to compound interest for the entirety of those 24 months. But the second deposit, I'm going to make another $50 deposit at the start of the second month, but it's only going to get to accrue interest for 23 months because it's in the second month already, right? Plus all the way until I get down to the 24th month, right? It's the last month, so my 24th deposit, right? And that's going to be a 50 times the 1 plus 0.06 over 12 to the first power, right? Because that's the last month I'm going to make a deposit. I make it the first month of every month, or the first day of every month, and that's the end of the deposit. Okay, so a couple things here. It might be worth figuring out what 1 plus 0.06 divided by 12 is, because we've had to write it a bunch of times, and it might be worth figuring it out. So it turns out that this thing right here, right, this 1 plus 0.06 over 12 is a 1.005. So I'm going to start using that instead because I don't feel like using the crazy, ugly monstrosity that I have. Okay, so what I want you to notice is it's more common in geometric sequences and series. You can do this any way you want, right? You could call this your first term and say that what you're doing essentially each time you do this is dividing by this whole ugly parenthesis, right? That's fine because that's how we get 1 power lower. The other way to think about this is to essentially write all the deposits in reverse order, right? And say, hey, my first value is this, right, to the first, or in fact, let's make our lives a little easier and just say, hey, you know what, I'm tired of writing that, so let's just write that it's this, right, so that's my first term, and then the next term would be this thing to the second, and then da-da-da-da-da-da. So basically, I just flipped the order. I said, hey, I'm just going to reverse the order, and at the end, I would end up with this 50 times 1.005 to the 23rd, and then a 50 times a 1.005 to the 24th, right? That's the sum. So this is the total amount of money that we made in those 2 years, right? Well, the trick is that this is a geometric sequence, right? In fact, and it's a series because of the addition. So this is these sequences of values are geometric. And then when I add them, I could find this by saying, oh, I get it. So this in this situation, my R, well, let's back up for a sec. My A is the whole first term, right? So my A is this 50 times 1.005, right? And my R is a 1.005. That's the rate I'd multiply every time because I'm taking this expression and timesing it by another one of those, which is what makes it squared and so on. So based on that situation, I know that this total value, if I erase the stuff at the top, this total value, right, the total amount of my money at the end of this time is going to use that formula A times 1 minus R to the N over 1 minus R, right? That's the formula for the sum of the the N terms in a geometric sequence, right? Sorry, it's not a 4, it's an N. Come on, brain. All right, okay. So in this situation, it would be the sum of those 24 terms, right? I'm going to have a total of 24 terms at the end of the day. So what's going to end up happening is that my total is going to be A, which was this thing, 1.005, right? That's my A, times 1 minus this 1.005 to the 24th divided by 1 minus this 1.005. Now notice if this were an infinite geometric series, it would not converge. It would end up being infinity, which makes sense because you're making money the whole time. So this is the thing I'm going to type in my calculator, right? And when I type it in my calculator, I'm going to get that it is approximately a $1,277.96. The one of the few times that we don't round to 3 places after the decimal is when we talk about money, because we usually go to 2 places unless we're told the whole dollar. So again, wanted to give you this example because you will see some like this in the book, and they can be a little bit tricky. So essentially the idea is that you treat each deposit separately, right? Each deposit is compounding its own interest monthly. It's just that each deposit is only doing a separate portion of how much is being compounded, right? So that's the idea. So like each deposit only has a certain number of months that it's compounding. Certainly the last deposit only compounds that 1 month, but the first deposit had all 24 months.